The production of light. In this lesson, we'll be talking about incandescence, LEDs, fluorescent lights, CFLs, electric discharge, phosphorescence, fluorescence, chemiluminescence, and bioluminescence. How your lesson works. Text that is bold and underlined is blank on your student copy. When you see it, pause the video and copy it into your notes. Whenever a video is available, you will see the video icon and a number. Refer to the additional resource document to find the correct video link. While you're watching the video, take a few jot notes on the main ideas that are covered. So you got to keep in mind that we only see things because light enters our eyes from objects around us. Some are luminous like the sun and can produce their own light, and some are non-luminous like us and only reflect light. So for instance, a book is only going to be seen when light, either from a light bulb or from the sun, shines on that book and then reflects into our eyes. If that light wasn't there in the first place, we wouldn't be able to see the book. Now the sun is a different example because the light from the sun is going to come directly into our eyes. So we're going to be able to see the sun without any other thing being there to reflect it into our eyes. The moon is another example, similar to the book, that is non-luminous. We can only see the moon when light from the sun hits the moon and shines into our eyes. So it looks something like that. Light from incandescence. Any object, as it gets hotter and hotter, will eventually produce light. So we see that right here. So once this metal gets hot enough, it starts glowing. In this case, it's going to glow in a yellowy orangey color. As it gets hotter and hotter, that color will eventually change from red to orange to yellow, and then to white, and then eventually to a bluish white as it gets really, really, really hot. This process of producing light as a result of high temperatures is called incandescence. Light from a burning candle is an example of incandescence as well. As you can see, the color of the flame is this orangey, yellowy color. Incandescent also occurs in incandescent light bulbs. A thin filament, usually made of tungsten, glows as electricity passes through it. So the tungsten gets really, really hot, and you can see the tungsten here, and you can also see it right here glowing. So as that tungsten gets really hot, as electricity is pumped through it, it starts to glow. And that's what makes our light bulbs light up. Now, only about 5 to 10% of the electricity going through the filament is actually converted to visible light. The rest of it is converted to heat, which is why incandescent bulbs get really hot once they've been on for only a short amount of time. Light from a light-emitting diode, otherwise known as an LED. An LED is an electronic device that emits light when electric current flows through it. It differs from an incandescent light as it does not require a filament, doesn't produce as much heat as a byproduct, it lasts a lot longer, and is much more energy efficient. LEDs are used in things like Christmas lights, illuminating signs, and traffic lights. Now they have a very useful in terms of something like Christmas lights. If you think about hanging Christmas lights on a Christmas tree, you don't want those lights getting really hot, otherwise it could catch fire on the tree. So having a light that doesn't get hot and still shines brightly is a very useful application of LEDs. Fluorescent lights. A fluorescent light makes use of both electric discharge and fluorescence. A fluorescent light tube is filled with a very low pressure mercury vapor, and the inner surface is coated with a fluorescent material. You can see two examples of our fluorescent lights here. They're typically the lights in the ceilings of most buildings like schools and offices, and they're also these curled bulbs that you should have in your home because they're a lot more energy efficient. When a fluorescent light is turned on, the electric current causes the mercury atoms to emit ultraviolet light. This ultraviolet light then strikes the inner surface of the tube, resulting in the production of visible light rays. So let's see what that would look like. We have our tube, our fluorescent tube, right here. And it's going to have electricity coming in, electricity coming out. That little zigzag line is going to represent our electricity, and these Hg are going to represent the mercury atoms inside. Now, when electric current gets pumped through this glass tube, it's going to cause the mercury atoms to emit ultraviolet light. Now, UV light wouldn't be very useful to us since we can't actually see UV light. But as soon as that UV light hits the inner surface of the fluorescent tube, that inner surface is going to convert that UV light to visible light for us to see, which is a pretty elegant process. Light from electric discharge is produced by an electric current passing through a gas. The electricity causes the gas to glow. So for example, lightning is electricity passing through the gas, the nitrogen and the oxygen in the air, and it causes it to glow. Neon signs are also an example of electric discharge light being produced. We fill the glass tubes of the sign up with a certain gas, then we run electricity through it, and we get a colored light. Light from phosphorescence. Objects that glow in the dark, such as wristwatches and some toys, are coated with phosphors, which give off light through a process called phosphorescence. These phosphors absorb light energy, then release it as visible light over time from seconds to hours, depending on the material. So you can see the phosphors glowing in this wristwatch. That wristwatch is exposed to regular light for a certain amount of time. The phosphors on the hands of the wristwatch absorb that energy, and then when the lights go out, it emits that energy as visible light for us to see. And same thing with these chemicals down here. You can see on the left, this first chemical is being exposed to regular light, and then as we turn down the lights, you can see that the chemicals are releasing the energy in the form of visible light, as we can still see it when the lights are off. Light from chemiluminescence. So as the name would imply, we're going to make some light, that's the luminescence part, using chemicals, that's the chemi part. So chemiluminescence is production of light as a direct byproduct of a chemical reaction. Light sticks or glow sticks are a good example of this. Bending the light stick in the middle causes a small glass vial inside to break, allowing the chemicals on the inside of the vial and the outside of the vial to mix. So if you were to zoom in and you were to take a look, you would see that the inner vial here has this red chemical, for instance, and it's totally shut off, so we'll close it off. And then surrounding that vial is a bigger container with this black chemical. And then as soon as we break it, as soon as we bend it in half, the chemicals from the red vial are able to spread out and mix with the black chemical. And as a result, we get the production of this light. Now, this light will last for as long as the chemical reaction goes on for. So if there's a lot of reactions taking place over a long period of time, then the glow sticks will last a long time. If the reaction happens quickly and then it's over, the glow sticks will be done very quickly. Light from bioluminescence. So now again, as the name would imply, luminescence, light, bio meaning living things. So when chemiluminescence occurs in living organisms, scientists call it bioluminescence. Bioluminescence occurs in a wide variety of organisms, including certain bacteria, fungi, marine invertebrates, like these jellyfish here, fish, glowworms, and fireflies. Now to end this lesson, this is a really interesting video. It talks a lot about bioluminescence and the wonders that we can see all around us. So before you end the lesson, make sure you have a look at this video. And that concludes our lesson on the production of light.